Welcome to solverfy.
The magnetic field exerts its force on each of the three segments of the wire due to the current in them. Now let's draw the three segments and label them. So let's say this is first segment, this is the second segment, and this is the third one. And current flowing in these segments is along this direction. So let's mark this as I, and magnetic field is into the plane of the screen. So this is the direction of magnetic field, and let's mark this B. Now force in each of the segment is given by right hand rule, and magnitude of the force is given by I times L times B. It's called as capital I, which is the current, times sine phi, and L is the length of the segment. So by right hand rule, so the direction of force in this segment will be in this direction. For this, the direction of force will be along this direction, and for this it will be in this direction. So let's call this F1, F2, and F3. Now let's find the magnitude of each of these forces. So for that, we need the length of each of this segment. So let's say the length of this segment is X. And we know the uh, length of the perpendicular component of the second segment, which is this length. So we know that this part is 0.4 meter, and we know the angle theta, which is 30 degree. So from here we can say that this segment will be, so basically tan theta is 0.4 meter over the length of this segment. Let's call this x2. That implies that x2 will be 0.4 meter over tan theta, where theta is 30 degree, and this gives the value to be 0.693 meter. That means the length of this is 0.693 meter. Now we know the total length, which is 1 meter, so we can subtract uh, the sum of these two lengths from the total to find the length of the segment. So that will be 0.307 minus x. So x comes from this factor. Now that we have for F2 we have the base and the height, we can find the hypotenuse or the length of the segment by Pythagoras theorem. So the length will be then 0.4 meter square plus 0.693 meter square, whole root over of that, and this gives the length to be 0.8 meter. So that's the length of this. So let's write all those values. So L1 is x, L2, the length of the second segment, is 0.8 meter, and L3 is 0.307 minus x meter. Now let's find the magnitude of each of these forces. So F1, so we will follow this equation. So F1 is I, which is given to be 6.5 ampere times L. So here L, we use L1 because we are finding the force in the first segment of wire, times B, and sine phi. So phi is 90 degree because current and magnetic field are perpendicular in each of the segments. So let's leave this like that. Similarly, F2 will be I L2 times P, and F3 will be I L3 times the magnetic field. Now let's add F1 plus F3 and see what we get, because the net force is, so let's find the net force first and then we'll have an idea of why we will be doing this. So now that we have all the expression for the magnitude of each of the forces and the direction, we can find the resultant force or the net force, which is going to be the vector sum of all these three forces. So we will use the component form. So the net force along x direction will be F2x plus F1x plus F3x. And you can see from here that F1 and F3 are perpendicular to the segment which is along x-axis. So the component of these forces along x-axis is going to be 0. So this is just gonna be F2x. And F2x is negative F2 cos 60 degree. So this angle is basically 60 degree because this is 30. So this is 30, so this is 30, and so this is 90 minus 30, and it's 60 degrees. So the component will be along this direction, which gives a negative sign here. And this value comes out to be negative 0.730 Newton. So for F2, we basically use the values over here, which are already listed over here. Now similarly, Fy is going to be F2y plus F1y plus F3y. Now I'm writing F1 and 3 close together because F1 and F3 point in the same direction. So it's useful to write them together. Now F2y will be F2 sine 60 degree. It points in the positive y direction, so there is no need of negative sign like that we did here. Plus, so if you add F1y and F3y, so F1y is basically F1 and F3y is basically F3. Now if you add these two, you'll see that the x cancel out and what we get. So let's do that first and see. So F1 is I times L1, which is x, times B. So let's not worry about the units right now. And F3 is I times L3, which is 0.037 0.307 minus x b. So f1 plus f3 will be I times b. So we take that common and we get this factor inside. So x and x cancel, and this is just IB 0.307. Now we can write meter here. So this is basically sum of the length of the segments of 1 and 3. So we calculate this, and this value comes out to be 0.559 Newton. And then we find F2 sine 60 degree. So F2 comes out to be 1.46, this value, and times sine 60 degree, which is root 3 over 2. And we get this value. Let's leave it like that. And we can directly add this value over here and simplify. So Fy is F2 sine 60 plus F1 plus F3, as you can see from this equation. So that's gonna be 1.83 Newton. Now we have Fx, the component of the net force along x direction and the component of the net force along y direction. So let's draw them. So Fx is in the negative x-axis. So the direction is this way, and Fy is positive, so along this way. And Fx is, I'm just taking the magnitude now because I have always taken the direction. I have already included the negative sign while taking the direction. So this is 0.730 Newton, and this is 1.83 Newton. Now, so from here we can say that the net force is going to point in this direction. And let's call this angle theta, or theta dash, because I have already taken theta to be this angle. So let's call this theta dash. So F will then be equal to the magnitude of the net force will be Fx square plus Fy square root over. And this comes out to be 1.97 Newton. And theta dash can be found from tan inverse Fy over Fx. And this angle comes out to be 68.3 degree. So now we have both the magnitude and direction of the net force that we want to find.